Okay, I think it's time we can get started. If those people can come in and sit down, still some free seats. Okay, right. Let's get started. Hi, everybody. Welcome. I am Kate Underhill. I'm going to be your master, or I don't know if that's mistress of ceremony today. Welcome to our fourth Future Space Transportation event today at ESA headquarters in Marinikis, as well as online on ESA Web TV. This is our first event after the incredibly successful ministerial conference last year. We're really happy to welcome everybody back here, or to see you for the first time, or to have you online for this spring session. We just want to mention that we're really pleased with this spring session this year because we have the most number of different country registrations. We have 23 different countries participating today, as well as a great mix of legacy actors, startups, institutes, SMEs. So we can really see that these sessions, how important they are, how useful they are, and they're really becoming the place to be for future space transportation in Europe. So for our events today, if I just come down specifically for today, we're after the Ministerial Conference 2025. We want to present to you certain aspects post-Ministerial Conference and then looking towards the future. You can see the agenda. You've got the agenda in front of you now. It's as usual, we've got 3 blocks. There's going to be some great panel discussions, there's some presentations, and there's a nice award ceremony as well. The blocks are organized around the kind of following aspects. So part 1 is from today to tomorrow, strategic concept. So future space transportation. Looking to the future, what does that mean? Block 2, from vision to delivery. So innovation in action. We have our strategic vision now. What are concretely the actions and the results we're getting from our projects? And then block 3, from implementation to opportunity. Impact and access. What are we doing within the ecosystem and how is it transforming what Europe does in terms of space transportation? There's going to be a coffee break after each block. Please take that time to refresh yourselves, have some great conversations, have some discussions, talk about the points you've seen during the block before. Please do remember to be back in time for the session. We have to keep our timing today for the online viewers and also to make sure they're on time for the networking cocktail at the end of the event. We're going to be taking pictures after every panel discussion. We're going to take pictures. This is really important for us to keep a nice memento of everything we've done today. Please just bear with us as we do the photo sessions, and then we'll move on to the next discussion. Those of us, those who are present in Marinikis, we have the coffee breaks, and at the end we will be rewarded by networking and cocktail at the end of block 3. So overall, in general, it's going to be starting off now with block 1. Our last event was it October last year? We were really talking about preparing the ministerial that happened in November 2025. Now it's happened, we'd like to present to you the key outcomes and the next steps. It's space transportation looking to the future. So to present this and to open today's event, I would like to welcome to the stage our first speakers. So we have Pier Domenico Oresta, who is Head of Future Space Transportation at ESA. And then, first of all, is going to be Jérôme Breteau, Special Advisor.
Thank you, Kate. Thank you, and good afternoon to all of you. I would like to, again, like Kate, welcome you to the spring edition of the annual Future Space Transportation event. And as we see, it's every time a bigger success. So I'm really, really, really pleased to see that. And I would like to thank a lot the FLPP team for inviting me to open this strategic context part. Sorry. So, as you know, ESA's Council at Ministerial level, CM25, took place in late November last year in Bremen, in Germany. And I would like to share with you 3 takeaways. I participated to the Ministerial and I was there, and I would like to share with you 3 takeaways of this CM25 that matter for space transportation. The first one is about trust and not thrust. The second is about transformation, and the third one is about, the second is about stabilization, and the third one is about transformation. And I would like to put an emphasis on future space transportation preparation, having in mind the CM28 perspective. So, first, a few facts and figures. CM25 exceeded our expectation with 22.3 billion subscription, which was beyond and above the expected 20 billion euro target that we had prior to the Ministerial. This is more than a number. It confirmed that space is now widely recognized as a strategic domain and an economic growth factor. And this is important. This is widely spread. It also reflected, that was my first point, trust in ESA, trust to turn political ambitions into programs and programs into delivered capabilities. Space transportation received, as you see it on the slide, the largest share of all the directorates with 4.4 billion euros. This confirmed that space transportation is central to Europe's autonomy and competitiveness. Above all, it secures Sevilla roadmap. If you remember, there was considered ministerial level prior to CM25 in Sevilla, and this roadmap was pertaining to operational continuity and near-term stability. It supports the exploitation of Ariane 6 and Vega C. It supports Europe's spaceport capabilities. But the most important message for today is this: with higher budgets comes higher expectation. The big budgets are big responsibilities. So the focus for us shifts from why to how fast, how smart, and how coherently we prepare the next generation of capabilities. In other words, CM25 did not only fund today's services, it also confirmed the perspective for future space transportation. Let me expand a little bit on what CM25 confirms for space transportation. First, stabilization remains a top priority. CM25 clearly prioritized securing operation of today's launchers with Ariane 6 and Vega C. In parallel, CM25 confirmed the paradigm shift through the European Launcher Challenge. The European Launcher Challenge call has been oversubscribed. I'm sure that you are aware of this. This has been a lot in the news, and that is a very strong signal. It means that the ecosystem globally is ready to move. And you know that we are very strong promoters and fostering very highly the ecosystem approach. So the purpose is to change the dynamics with this program, increase competition where it makes sense, and accelerate learning cycles through demonstration. First point. Second point, as you also already know, I'm sure, the pace of future preparation is constrained. Subscription came in below the proposal level. I would say a side effect of the prioritization that I was just referring to before. So we cannot do everything at once. This means that we must prioritize and sequence. We must focus on what de-risks the next steps the fastest way. Typically, technology maturation, system-level demonstration, and operational concept that can scale. This is where programs like FLPP are essential. They connect technology roadmaps to flight demonstration, they build evidence, and they reduce risk before major development decision, having in perspective CM28 once again. And here, what is important is that CM25 and the member states reconfirm the objective of future space transportation preparation to mature new systems and breakthrough technologies and bring new industrial players into the game. Third point, priority on the preparation topics has been confirmed. That was not for granted. That was a personal source of satisfaction after the CM25. Heavier reusability, typically with reusable stages and reusable propulsion, in-space transportation and orbital infrastructure are confirmed as priorities, top priorities, and more open and competitive procurement in terms of methodology and approach to implement these priorities where appropriate. This is a big shift. It means that we are heading towards end-to-end space transportation, from liftoff to mobility in orbit, to servicing, assembly, and manufacturing support, and to the infrastructure that makes these activities routine. Routine is important. Why these priorities? Because they change the economics and the speed. Reusability can increase cadence and lower cost per mission. This is a no-brainer. In-space transportation enables flexibility, persistence, dual objective, and resilience in orbit, and orbital infrastructure creates markets that can scale. This is a factor of economical growth. Open and competitive procurement is a tool to move faster. It creates multiple paths to success, it rewards performance, and it helps us in Europe to learn by doing. Of course, this must go with smart system architecture and clear interfaces, and I know that the FLPP team is working hard on interoperability and European positioning on interfaces. CM25 also included a defense and security mandate, last but not least. This is a strong point. This underlines that space transportation is foundational for dual-use capabilities. We'll discuss that. And for freedom of action in space, which is important for Europe. So orbital infrastructure and in-space transportation are not only an economic opportunity, they are also a strategic necessity. This is why I encourage you, I look at my colleagues, I encourage you to follow the panel. I have the honor to participate at 1845 on ISOS and ISAB, where this dual approach will be discussed more in depth. Last point, and finally, while Europe aligns, global competition is accelerating. Overseas actors are moving fast. So the key question becomes execution and scale. Do we acquire this new capability through a shared transnational approach, building efforts, building critical mass, and avoiding duplication? Or do we risk fragmentation through parallel national tracks? This will be a question for the next 3 years. And let me be very practical about what this requires. We need very few clear flagship lines of effort. You have a certain number around me. We need measurable milestones, and we need early results that can be shown in the next 3 years. But we don't need perfect systems on paper, but demonstration that retire risk and procurement models that attract the best ideas. Between now and CM28, the best answer is proof through progress, clear roadmaps, visible demonstration, and implementation that builds confidence with member states and users. For me, this is precisely why CM25 is an intermediate but essential step. It stabilizes the present and it confirms the direction important for future preparation towards CM20. I see that I'm out of time, so I will close now. And let me close with the 3 takeaways I started with. Sorry for this, Piero. CM25 confirms trust in ESA, my first takeaway, and the strategic importance of space transportation. Second takeaway, stabilization. We secure operational launches and continuity of service. Transformation, third takeaway. We align on reusability and in-space infrastructure. We use more open and competitive approaches, and we address an increasingly important dual-use dimension. Voilà, that's the 3 takeaways. And with that, I am convinced that future space transportation is now on good track. I am pleased to hand over to Piero, who will present the post-CM25 implementation approach. I thank you for your attention and for your continued support all along these years. Thank you, and I wish you a good afternoon.
Good morning, everybody. Thank you for being there. It's really a pleasure to speak in front of this audience. I'm the last arriving in the family. I took over Jerome in mid-January or something like that. And I discovered a lot of things. So thank you very much for training me in this, for example, to training me using a microphone. But you can do a lot to train me on how to prepare better the future, because one of the key elements, it's me that, one of the key conviction we have in ESA and the Space Transportation Directorate especially is that industry has a lot to propose, has a lot of good ideas, and we need to learn and to implement and to let the implementation possible in the best way. We had not an easy result of the Ministerial in that sense, but we are not the only one, because as Jerome explained, a lot of resources were drawn, but very important action, stabilization from one end, and the introduction of a new paradigm for launch exploitation on the other end, and still the implementation of Sevilla that has drawn a lot of resources. So finally, FLPP and other programs of space transportation did not get exactly the amount of money that was requested, especially not with the geographical distribution that was the preferred one. So if you like to joke on me, and now I am like the characters of the Inferno or the Divina Commedia of Dante Alighieri. I'm suffering from the law of the contrappasso. So I created draw resources by creating the need of the exploitation of Ariane 6, especially in Vega, and now I suffer from the lack of resources in FLPP. Good for me, but I'm sure, since I'm very meridional, practical guy, I'm sure that we could do, even with the resources we have, a lot for the progress of Europe together. So listening what industry proposes, discussing with delegations, having feedback towards industries, getting the authorization of the delegation on what we propose finally. And this is the way we are building the implementation plan that this time here is extremely important, because we will work with roughly 65% of the amount we requested at the Ministerial. And I'm really lucky because it is already a very good result. So no one is authorized to complain about that. It is a good result. We can make things like this. And what we will do, basically we will keep going on the whole plan of FLPP activities, distinguished in the four pillars that you may already know. First, for technological maturation. Best, for introduction of reusability and maturation of reusability concept and systems. Trust. Trust is very important. I want to spend one word more on trust, because the big propulsion is a key enabler for whatever it will be the future of space transportation. We want to go behind what has been done till now in the development of technological maturation of the high trust engines and systems. We want to invest really in that area, because we think that it is a key enabler also for the target of the heavy reusable launcher. So this will be an element on which we will spend a big effort on trying to maximize the synergies and convergences on all the technological roadmaps in order to come at the end with 1 minute left and in the second consortium that can deliver what we are looking for. Last, my preferred one, if I can say, in space proof of concept, because this is bringing space transportation at the gate with the new era, in which access to space is complemented by in space, I don't think here in this consortium I shall spend many words in explaining why this is extremely important. But we can imagine a lot of different scenarios in which the space infrastructure needs not only to be deployed, but it needs to be preserved from undesirable events. It is a sort of special application of space situational awareness, in which the infrastructure, and therefore the good of Europe, is no longer on ground on the Earth, but it is in space. This is not a probable scenario. It is a certain scenario that will happen in a few years, and we need very likely at least the same amount of years in order to be ready for it. So this is exactly the time in which we cannot fail. We shall go, and we shall succeed in implementing these new capacities. This requires a sort of belief. Sometimes I do understand when I discuss with delegation, when I discuss with certain reluctant partners. I do understand the vision is, oh, we will see later. No, the vision is we shall see today. And I know that there are a lot of even national initiative and private initiative, either on big propulsion and in reusability and in space transportation, that needs to be made coherent and synergic. We are fully engaged to do so. And ESA will play its role as it has always done. Thank you very much.
Thank you very much, Pierre. Job, can you just stand at the front of the stage to get your photo taken? First photo, official photo of the day. Lovely, thank you very much. Right, after that introduction from Piero and Joe, we're going to move on to our first panel discussion. Well, we've talked a lot already about the Ministerial Conference, results of the Ministerial Conference, the budget. What we haven't actually discussed is one of the really interesting successes coming out from that conference is the new member states, the newer member states deciding to get involved with FLPP for the first time, or getting re-involved with FLPP and the preparation of future space transportation in Europe. So it's going to be really interesting today to hear from some of these new member states about their country's strategic perspective, their current capabilities, and then their industrial layout. So to moderate the session, I'm going to introduce on stage my colleague Jean-Christophe Barré.
Thank you, Kate. And welcome everyone to this panel. So my name is Jean-Christophe Barré. I'm part of the FLPP team, and I'm very happy to moderate this panel today. As you may know, FLPP is looking to expand its ecosystem continuously. And since the Ministerial Conference of 2025, 4 new member states have renewed their interest in FLPP: Hungary, Luxembourg, Greece, and the United Kingdom. And so we would like to give them the floor to introduce themselves and to share their perspectives. And today, 2 of them could be present with us. So let me introduce Bianca Gall. So Bianca works for the Hungarian Ministry for National Economy. Please join us. Thank you. Please take a seat. And Bob Lamboré. Bob is working for the Luxembourg Space Agency and is also delegate for Luxembourg. Please join us. Take a seat. So thank you for being here. Just before giving you the floor, there's few words to set the stage. So this panel will last 30 minutes, starting with presentation from our delegates, 5 minutes each, followed by moderated questions, then an open discussion, and if we have time, question from the audience. So I think now it's perfect opportunity to discuss about your country priorities, space legacy, and to let the audience know that it can look for industrial partners in your countries. And if you are ready, Blanca, we can start with the presentation.
Good afternoon. It is an honor to be part of today's event, and I'm especially pleased to offer you an insight into Hungary's activities and achievements in space. So I would like to start my presentation with a historical context. So in 1946, Zoltán Baj performed one of the world's first successful radar echo experiments on the moon, founding radar astronomy. 34 years later, in 1980, Bertalan Farkas became the first Hungarian in space. This era saw the debut of the Pille dosimeter and the Vega probes, where Hungarian engineers developed the central data unit to study Halley's Comet. Moving into the 21st century, our next milestone was the launch of Masat-1, Hungary's first satellite. It was followed by the SMOG series, creating the first global electrosmog map, and the MRC-100, a so-called space lab that achieved 100% mission success until its 2025 re-entry. I wish to mention two milestones in 2025 that carry special importance and hold a very special place in our hearts. The first was the fully lunar water snooper landed on the moon, South Pole, successfully transmitting data from the lunar surface. And the next one, the Hungarian to Orbit program, when Kaput Tibor joined the AX4 mission to the ISS, conducting 25 Hungarian scientific experiments over 18 days. Next slide, please. Thank you very much. In this part, I would like to mention two Hungarian companies. The Admatis is a leader in space transportation, specializing in active and passive thermal control, with hardware proven across 25 missions from Leo to Jupiter. The company provides critical thermal, structural, and navigation components, marker supporting navigation for in-orbit docking. Beyond flight hardware, the company delivers essential MGSE solutions for spacecraft handling. The other Hungarian company is the AEDUS company, which drives space innovation through high-performance propulsion and advanced material science. The company specialized in ion thrusters, rotating detonation engines, and mission-critical hardware like piezo waves. Beyond engines, the company leads in radiation protection for deep space mission and promotes sustainability via design for demise solution. Their expertise is underpinned by industrial 3D laser manufacturing, delivering high-precision components to the space and energy markets. Next slide, please. This is our last slide, and I would like to mention a very promising Hungarian company, which is the Machine Intelligence. Machine Intelligence is a Hungarian SME specialized in advanced artificial intelligence for industrial quality control and space application, with a focus on computer vision, synthetic data generation, and onboard deep learning for guidance, navigation and control subsystem. Machine intelligence engineered and field-tested a sophisticated solution for identifying faint near-Earth objects. The system processes live telescopes data streams with extreme reliability, showcasing robust deep learning architectures that excel in noisy, low-signal environments. And this is the end of my presentation. Thank you very much for your attention.
Thank you, Bianca, for your presentation. You can keep your microphone on because I have some questions for you, if I may. In which way the FLPP ecosystem can help your national technology development and this industrial competitiveness, and with which role are you aiming at for Hungary in this ecosystem?
So the FLPP ecosystem boosts Hungary's competitiveness by integrating domestic companies for the European space supply chain through development. By participating, Hungary developed specialized niche technologies such as advanced material and electronics that bridge the gap between research and industrial application. Hungary's strategic goal is to become a reliable subsystem supplier, providing innovative and cost-effective components. This involvement grants Hungarian firms to technical excellence needed to compete in the global commercial market. The FLPP program builds a high-value industrial base that can strengthen Hungary's position in the international space market.
Thank you for your answer. I have another one. Yes, I have another one. Which points in the FLPP roadmap align most with your national strategic priorities? And how would you handle the coherence between the national and the European objectives?
So Hungary's space strategy primarily focuses on industrial development and integration into the internal space industry value chain. The alignment with FLPP activities is mainly visible at the level of technological subsystem and industrial participation. The first programs show a strong alignment because small and medium-sized enterprises as well as research institutes can participate, and it matches Hungary's objectives to strengthen high-value added technological niche areas. In this area, possible contributions can be AI-based onboard system and advanced materials. In connection with the INSPOC domain shows moderate alignment with Hungarian priorities, as the development of technologies required for in-space operations, such as autonomous navigation systems, sensors, and onboard software fits well with Hungary's research-intensive space capabilities. Hungary is currently more likely to participate as a subsystem developer and technological partner rather than as an integrator of a complete in-space service system. Coherence between national and European activities can be ensured by focusing Hungary's participation in FLPP on technological areas where national industry and research capabilities are competitive. It is also important to align national R&D programs and funding instruments with ESA technology roadmaps.
Thanks for this long answer. Actually, do you have something to add before I give the floor to Bob? No? Okay. So, Bob, if you are ready and if you agree, you can start with your presentation.
Thank you. Good afternoon. My name is Bob Lombre from the Luxembourg Space Agency. Thank you for the opportunity to present a bit our perspective on space transportation. So to start, I would like to share a few thoughts on space activities in Luxembourg. So it all started mid of the 80s with a large satellite service operator that probably most of you know. ACS was founded in 85, and then it was among the first customers in 88 on Ariane 4. I think this is a very important event in space for Luxembourg, as it shaped a bit on especially the successful development of that company on a commercial level. That shaped a lot the way how Luxembourgers see space, and also how politicians are supporting space overall. Then in 2005, so 20 years later, so it started 20 years before we joined the European Space Agency. Luxembourg became the 17th member of the European Space Agency with the idea to diversify the space industry in Luxembourg, which until then was centered a lot around satellite communication. In 2016, the government launched a very forward-looking initiative on space resources. It's the Space Resource.eu initiative. It's important to understand that it's not a mission, it's not a technology program itself, but it sets forward the ambition that in the future you should be able to use space resources in space, or eventually on Earth, but initially the idea was to use them in space. So the initiative creates the framework to do so. We are very active on the legal level, but we also support industry to develop the technologies for these use cases. We work with research centers and university to create the talent. And we also recently established a European Space Resource Innovation Center in Luxembourg with ESA on that topic. Then only in 2018, the government decided to create the Luxembourg Space Agency as a separate entity. And then finally, I think most relevant for this event today, last year we then joined FLPP. On the next slide, just briefly our two experiences so far in FLPP. On one side, we had Lift Me Off, a small startup in Luxembourg that was involved in an in-spock activity on rendezvous and proximity operation and docking. And then a second activity we support is the development of a ground, ground demonstrator for in-orbit cryogenic refueling together with the exploration company and Absolute Systems in Luxembourg. I think that's fairly limited for other countries, but it's an interesting start for this program. Then maybe to finish the presentation, so our mandate is to diversify the national space industry. And over the last 10 years, we went from 20 companies in space to approximately 80. So in the link and also the QR code will lead you to space, what we call space directory on our website, where you see all the companies, short description, contact details of all these companies. I just picked a few on here that I believe are quite relevant for this environment, showing a bit the diversity of that ecosystem of space industry. We have companies like Space Cargo, the exploration Space Cargo Unlimited, and the exploration company looking at in-space logistic, cargo delivery to space and back to Earth, to the exploration company Absolute System working on cryogenic refueling. Then we have a Lift Me Off that was recently, 2 weeks ago, acquired by Infinite Orbits, working on satellite refueling and life extension of satellite systems. We have ClearSpace, they're also working in Luxembourg on life extension of satellites. Redwire, they are building robotic space systems to develop proximity, to be used in proximity operations and in space servicing. We have Saturn Technology, They are working on, they are an expert in advanced 3D, metal 3D printing, and they're also supplying parts to some of the launchers at the moment. And then we have Amtronics working on specialized electronics, Bradford having propulsion system, and the last logo is Space Backend. They're working on integration and intelligence. Then on the very right of the slide, you see on the academic level, we have one university in Luxembourg. They have a zero-G lab where they can develop technologies for docking and in-space servicing. And we have the Luxembourg Institute of Science and Technology. They are an expert mainly in very different materials. Thank you.
Thank you, Bob, for your presentation. So I also have some questions for you. And I see that you already have some experience with FLPP projects. What is your long-term vision for integrating the FLPP technologies into your national strategic priorities?
So maybe to explain a bit why we joined FLPP, I think it all started with the Space Resource Initiative. So first of all, it opened the door to exploration and to in-space activities beyond the traditional satellite communication. We were very well aware in Luxembourg. And in that initiative, space resources, the first products we eventually will be able to use are gases, hydrogen, oxygen, and so on. And so with the idea to use those resources, you need to be able to manage, to store them, to transfer them, and to use them. So basically, that's a bit the initial thinking behind that. Now it's obvious that it's very difficult to predict when we'll be able to produce space resource-based products. So I think we are very aware that this is a very long term, but we believe in a time with increased space activities, with increased need for space logistics, in space mobility, there's a case to mature those technologies today, well before you can actually use space products, space resource-based products. So I think the idea here was a bit. It's around refueling of refueling services in space, and then once there was an opportunity to support and work together with the exploration company and Absolute Systems on this cryogenics refueling, that was a bit the motivation then to finally join FLPP and also develop these technologies in the European together with European players.
Okay, thank you. And talking about technologies, which emerging technologies does Luxembourg plan to develop with FLPP initiative or demonstrators?
Yes, on that, I think it's important to understand that Luxembourg Space Agency, we're not a traditional space agency in the sense we do not have our missions, we do not have our own internal space technology roadmap. So I think the direct answer is a bit difficult for me. But our mandate is to develop to diversify the national industry and grow the space industry specifically. And so we work very close with industry to understand what are the technologies that will be needed in the next years. And also especially, we always believe that commercial utilization of those technologies is a key element to grow an industry, and to make also these companies succeed in the long term. So this said, I think now in the context of space transportation, we see growing interest for several technologies, and we also have companies, as I mentioned earlier, in Luxembourg active in this field. So first of all, it's about logistics, in-space logistics. In-space manufacturing is also a growing field. So there we have, this includes cargo to space, cargo back from space, exchanging cargo in space, all of these topics. Obviously, with this also comes proximity operation in a broader sense, being able to navigate around objects, being able to dock objects, all the robotics that comes with it. And then last but not least, I think it's all about all these different use cases, from refueling, cryogenics, but not only cryogenics. I think having the largest European satellite operator in Europe, extending and refueling satellites will be more important in the future. Being able to move in space, change orbital planes more rapidly will be another use case. And then also for exploration, and especially in the context of lunar exploration, that's where then cryogenic refueling becomes an important or interesting element.
Thank you for your answer. Yes, I look at the clock. May we have time for no? so it's time to close this panel. Thank you very much for sharing your perspectives. So I think now I will give the floor to Kate, but I don't forget there is a photo.
Now it's a photo of the panel. Thank you very much, JC, Bianca, and Bob. It was really interesting to hear more about Hungary and Luxembourg, your ambitions and your capabilities. Thanks, JC. Okay, so this was newer member states, FLPP, looking to the future of what they want to do with us. The next topic is of really great importance, considering because I wrote a week ago, considering the current complex geopolitical context, and I think it's got even more true or even worse since I last wrote it, as well as the increased competitive pressure felt by Europe and European companies. We need to ensure European autonomy in key strategic areas, which of course includes space transportation. We will of course continue to cooperate with non-ESA member states, but we need to make sure that we have all critical technologies, products and systems in Europe. So recently, I think you're all aware, the European Commission has announced big plans for defence and security budgets. The objective is to boost the defence and security sector within Europe with high expectations of 2030. This is something where it's great. We've got the budget, we've got the strategic incentive, and now we need to start delivering. So in this panel, my colleague Frédéric Jousset will address how dual use needs are transforming the in-space landscape by enforcing new needs and new tie-ups. Fred, it's up to you.
Thank you, Kate. So good afternoon, everybody. Thank you for being here and following us on the web streaming. So during the last event, last autumn session in October, we introduced the subject of the dual use and illustrating how a public and private actor could work together on safety-related issues. As Kate mentioned, the context is evolving rapidly, requiring a shift on mindset in Europe, but also requiring a swift implementation to remain present in the global game. We have the example of the in-space refueling in the US. Independently for the who does what, today we will put our attention of the expectation, constraints, and opportunity that the dual use can bring to the in-space transportation business on the global European scale. I also take this occasion to tease a little bit about tomorrow's session on access to space, during which a similar panel will take place for this particular domain. And now, to hold this panel, I will welcome on stage my distinguished panelists. So first, ladies first, Victoria Cortez from Astroscale. Victoria is commercial manager in this company. I will welcome on stage the Colonel Marcin Mazot, Vice President of Polsa, intelligence officer, specialist of Earth observation and space situational awareness. Welcome, Marcy. I will welcome Jan Schnabel, German Space Agency at DLR. And now welcome Enrico Cavallini, Head of Access to Space and In-Space Servicing at the Italian Space Agency, ASI. Welcome, Enrico. And last, I will welcome François Chopard, CEO and founder of Starburst. And I will leave the word to, you can take a micro here. Yeah. I will now leave the word, the stage to François for a little introduction. Thank you.
Yeah, good afternoon, everyone. Thank you, Frederic, for the opportunity. And I'm just going to state a few things about why dual use and in-space transportation has become a key thing. Obviously, hopefully it will not be too obvious for most of you, but I thought it was good to bring a couple of reminders. Why dual use and why in-space transportation? In-space transportation is part of the more global, in-space services, which is part of the space business. And dual use for space in the past had a different meaning. When I started my career, we were more talking about solar panel, lithium batteries, which were technology developed for space and applied to different industries. And actually, the ESA BIC, at the beginning, were created in that particular purpose. Today, dual use has a different meaning. Today, dual use is we are talking about space technology or services that have been developed for mostly commercial application, and we are looking at, can we sell it to government also, but also to the defense industry, and that's mostly the case now. Yes. So why does it matter now, right? Dual use and this technology for defense. If we go back a little bit, the first time where the American realized that space was a key asset for defense was the second Gulf War or the Iraqi War, where they were able to combine their space assets in terms of Earth observations, GPS, and communication, and that gave them a great superiority for that battlefield. 10 years later, end of the 2010, they realized that China was growing their capabilities in space in a much faster way that they expected, and that they needed to react and develop or be much more efficient and proactive in terms of space technologies. And at that time, there was another trend, which were the Silicon Valley space startups. Of course, we heard about SpaceX, Planet Lab, and a few others that were proposing disruptive services, new type of services that were not imagined before at much lower cost or price. And so the combination of these two elements, the Pentagon looking at space again in a much deeper way, and these new players proposing services at the beginning for the commercial sectors. And why for the commercial sectors is that at that time, 10 years ago, when I was in the Silicon Valley, defense was almost like a taboo. VC would not allow space startups to address or try to sell their product to the Pentagon or to address the defense market, because lead time and administrative processes were way too long, were too complicated, and VC didn't want their startups to enter that way. But it changes with all the amount of money that the Pentagon threw on the table, the creation of the Space Force, the DIU, Defense Innovation Units, and so in 2018, 2019, then the two words started to work together. And then dual use for space activities became a thing. And all these commercial space startups that were developing their products, struggling honestly to sell them to the commercial market. Even Planet Lab, trying to sell Earth observation pictures to the commercial market was really struggling. And still today, 80% of their business is governments and to some extent defense. then the two worlds collide in a good way. And then the entire ecosystem started to work together. And so all these commercial applications started to make sense for the defense. Europe, we always take things a couple of years later. And so now in Europe, we are starting to think about dual use for space. And then a couple of years back at Space Symposium, one of the generals for the Air Force was saying, we need the equivalent of the F-16 in space. If space is becoming a strategic asset, if we are at risk with China, we need our own F-16. So what does it mean, an F-16 in space? That's something that they are still working on. But if we want that type of product, we need in-space infrastructure. We need new type of propellants. We need new type of engines, and we need to be able to refuel in space. And so now is the time, also in Europe, with the European Space Agency leading the way and the FLPP organization to really push that topic. 10 years ago, just for commercial, it would not make sense. And a couple of players that started in that field, are struggling. But now I think is the time. And I'm glad we are all here together to discuss about these applications for governments, defense, and commercial. But I think commercial will come later. And it's a no-brainer that this specification needs to be worked, jointly between commercial, and it would not make sense to develop a commercial service different from a defense or military service. And that's where we are going to talk right now. Thank you.
Thank you a lot, François, for this insightful introduction. So waiting for the F-16 in space, not mentioning the TIE fighter that may come in some years. Let's start with the geopolitical context that became complex, and competition pressure is increasing, as we are seeing also. So we see that other nations, including US and China, you mentioned them, target operational in space systems and infrastructure in the rather short terms. So in your opinion, what today's context existing in Europe? So on this one, I would like to have first maybe an insight from Polsa and Marcin, if you would. Thank you.
Yes, thank you. Good afternoon. Thank you for having me here. That's my first time for the FLPP, so it's good to show that also military are not always behind the curtains and behind the walls. It's not a part of taboo, but it's part of today existence, right? Going back to your question, I would say yes, of course, the geopolitical situation has changed dramatically, and in Europe, of course, we have to change the approach of thinking of resilience, of sovereignty, autonomy, and so on. And there's no doubt, and I don't have to convince you that the space technology helps to run the national interest, to help to exist the countries and the continent, of course. And regardless of different users, the military or the civilian ones, is always about the same issues, about sovereignty and independence. And when you ask me about the situation with US or with China, we as a Europe, we can't be too far behind. We can't stay and wait for in the same position. We have to follow some directions. We have to invest, and definitely the launch autonomy is at this moment our European Achilles heel, and we have to stand up and to find sufficient solutions to be able to provide our assets to space.
Thank you, Marcin. Maybe François, to complement on this about the geopolitical context.
Yeah, just a few. We've seen with the conflicts between Ukraine and Russia, that's the first thing that happened before anything on the ground started to move is the try from the Russian to jam the satellite communication and mostly the box on the ground. We've seen that later on, Earth observations from the US is providing a huge amount of intel to the Ukrainian soldiers on the ground. We've seen that in the conflict between Israel and the countries around, and especially now with Iran, when we monitor the Hormuz straits and all the ships that are trying blocked or trying to move. Space is a critical asset in that conditions. As Europeans, we need our own sovereignty. We used to rely heavily on the US. It would be safe to rely a bit less with them, even if we are part of NATO. And in case of a conflict with a much bigger enemy like China, there will be definitely a war in space, right? Definitely, and we need to be prepared for that. And again, having assets and refueling is part of that enabler.
Okay, thank you, François. Yes, exactly. We've seen that since 2019, space is now an operational domain for NATO. So if we look a little bit more then, because we mentioned the strategic use of space for on-ground operation, but now let's look to in space on the expectation of understanding of a dual use, what it means for in space. Are civil and defense separated in two sides of the same coin, or are they separated on the two sides of the same coin? Excuse me. For this, I would like to hear first Enrico for ASI on this topic. Thank you.
Thank you for the question. It's like the boat in the sense that, from a certain point of view, they are on, let's say, the same kind, but they need to be managed in a different way. What they are separated, what is separating them is requirements that are aimed at in order to respond to defense and security needs. That is not what is used normally for the civilian applications. And this is also implies to have, let's say, the prerogative by national sovereignty point of view that is belonging by policy point of view to member states and to the let's say, European Commission. That's quite important to be said. There is behind the matter of security and defense. Technology, by a certain point of view, can be dual use from scratch. Yes, what is preventing one technology to be used for dual use application is the fact that we need to inject security requirements very clearly and defense requirements. And because of this, let's say what is changing also the level of protection of that kind of technology on the services that is behind, because it implies that it's not exactly the same that is used in the civilian part, or there is a part of the information that are very much protected because there is a need behind that is not just a civilian one, not exactly the civilian one at least. And it's something that it's more it's not a matter of just of expectation. It's the fact that we need security when speaking about defense. Actually.
Okay, thank you, Enrico. So yes, you mentioned interoperability. I think what I understand so from your answer in the technology, you can have an extension on interoperability. Jan, for German Space Agency, what will be your opinion on that topic?
Testing. Okay, seems to work. Thank you. Yeah, thank you to be here. Thank you, Enrico. What I would say from German Space Agency side, what's quite important is to talk about the context. So what is the context we are talking about in dual use? What What I'm trying to say is it either in the ESA context or is it in the EU context? In the ESA context, the focus should be on the civilian side. And if there is later a possibility to use these civilian developments from ESA side to adapt them for dual use specific operations in defense. And that could be done on a national scale or outside of ESA. But from our perspective, I would say this is the main question basically. So when we talk about the European context, obviously we are going above, outside and beyond ESA. That can be the case to get dual use applications, but within ESA it should be regulated.
Okay, thank you, Jan. Yeah, sure. It can be, as we said, two sides of the same coin. We can see that either it's a technological opportunity or an economical opportunity. So today, I think the equilibrium is shifting from what François said in his introduction, from going from defense to civilian, but now maybe defense sustaining civilian activities in space and also in space transportation. Marcin, would you like to also react on this particular topic?
Yeah, definitely there are two types of users, right? But we have to think about the goal, what is behind. And I think the goal is to have common shared access to space or capabilities, access to products, data, services. There's no time to think that soldiers running somewhere on training areas using different type of tools or capabilities and industry providing solutions. It's time to build the competencies for specific tools and be ready to be used in need. When we look into Ukraine, there's no single space capabilities which cannot be used for defense purposes, and that's the main point. And from police perspective and police space agency, we see that it's important to be prepared to deliver technology and tools for different type of users, regardless if they are classified or not.
Yeah, exactly. Ukraine has shown us that every kind of technology can be used differently, let's say, and they have been very, I would say, inventive on that. And now, if we look to the industrial side, given the short expected timeline, the very high expectation on the stakes that we have here in Europe, how can we ensure that the industry will be able to deliver an answer defense need in its space at European level? So I will leave the floor to Victoria for us to scale on that. Thank you.
Thank you very much for inviting us to be here. I think the joint perspective of institutions and industry is essential so that we make progress and way forward. In terms of Astroscale, just to give a brief overview for those who maybe are not familiar with us, we're an in-orbit servicing capability company. We develop these capabilities both for sustainable space, but also resilience of in space infrastructure. So there you see our dual perspective on the markets that are before us. And I think industry will follow wherever policy sets kind of the bar. So as we're opening the frontier to more dual use activity, industry is interested to move forward in the dynamic, not only because it brings a diversified revenue ecosystem, but it also provides opportunities to grow technologies. As we heard very clearly from Enrico, we share the same perspective. Some of the core building block technologies are the same regardless of a civilian and defense application. What is important for industry to be able to advance is this change in mindset on the operational context. And for that, it's the continuous dialogue between military institutions and industry that is helpful to help us go in that pathway to be able to meet requirements. For instance, for SMEs and startups, it may be a bit of a hurdle at the initial stage to be compliant with clearances, the security levels which are increased for, cybersecurity, sensitive data, and so forth. But with due collaboration and discussion, I think we can make progress.
Very well, thank you. Ian, for the LR, maybe on this question about the way to drive industry and to be with them, to accompany them to work on the dual use topics.
Yes. Basically, the key part is the communication. As you might know, the earliest communication with industry on what are the requirements, what is the way forward on these topics. Also, again, to hammer that point home, the differentiation between ESA and the EU context is absolutely necessary on that part. But nonetheless, communication and early engagement, basically.
Okay, thank you. So we just mentioned and discussed about the requirements. And that is, I think, also a very central point when we said, when we are trying to know when and how to include potential difference use case in the design of a technology or a system. Everything comes back then to the requirements you will use to design your technology or system. So if we look to the notion of security by design, maybe we'll ask Enrico to comment on that, because in your first answer you already mentioned this aspect of requirements.
Thank you for let's say it's indeed. Let's say first, at the Italian Space Agency, we have quite a long-running experience around the dual-use system. Let's say just to mention one that is a flagship program for Italy. It's the Cosmos Skymet. We are now at the second generation. It was this system was developed both the first and the second generation really together with the Ministry of Defense all together. So there was for this system there was dual-use application, and so let's say from the scratch, from the beginning, the system was conceived together with the MOD, and we have let's say a program which is running with the MOD people as a joint team. But what we have done more recently, in terms of security by design, today, let's say, especially, let's say, my knowledge for access to space and orbit servicing, that is the topic also of today, we are injecting security by design since the very beginning. Either it is a system or a techno, that does not matter. We have to consider since the beginning what are the implications of what we are doing, what the technology is aimed at, and how to, let's say, properly consider the fact that it can have implications that are, let's say, not only civilian one. And so, in order to make any possible endeavor to another, let's say, possible application operation, either operational, we have to consider it since the beginning and to continue in considering it as long as the techno is improving or can deliver something. It's something we are doing. Security by design is one of the changes we did from 7 to 5 years ago, more or less. And this is something we are doing today, let's say every day, let me say such that. Another thing to add, today we have a national law that is implying resilience as one of the pillars for being authorized to make space activities. This does not imply, let's say, to have let's say, a very high level of resilience, but to show that the space activity is resilient as it is, because there are, let's say, international implications with even to commercial activities. And so, whatever space activity, I'm not talking about dual use now. Even commercial one should be resilient in the evolving context of space. Thank you.
Thank you, Enrico. Yes, you're right. Economic defense, which in brackets is part of the resilience of a country, of course. François, any complement on security by design?
Not much on security by design, because I think it's pretty much obvious, right? I was more coming back to the use cases, and when you look at on the commercial side and the military side, in-space transformation started as a purely commercial use case, pushed by SpaceX and a few others, assuming that it's cheaper to save fuel in low Earth orbit, and then to go explore the geo or even further away, whether it's Mars or meteorites. And I remember highly supported startups by Luxembourg, the Planetary Resources, amazing founder and amazing company, where they planned to send ships from low Earth orbits, right, to mine some asteroid and then come back. And low Earth orbit was a critical asset. So it's an old use case, right? But commercially speaking, it was still very much too early, and it's probably too early for now. But the military are making it a much more viable one to refuel either their own assets, because at some point to extend life of critical satellites, it will be cheaper to refuel them from low Earth orbit. And right now, what we have seen is that these assets have been extended through the launch of a dedicated vehicle from Earth to low Earth orbit. But it would make more sense to combine, this refueling from low Earth orbit. It has shifted a little bit from the moon, because the moon is becoming, based on the US and China threats, another critical assets. And so now they're talking about instead of putting refueling in low Earth orbit, why not putting it on the moon? But at the end, we can clearly see that the evolvements of this use case are going to be taken over by the military. And one of the key technical aspects is the refueling interface. How do you dock? How do you transfer your fluid from one container to the other? And that should be, hopefully, a shared specification between commercial and military. And hopefully, these assets will be shared. The only thing about the military is, as you said, they need to be much more protected, right? They can't be shared with everyone, and that's the key element where. Yeah, secured by design, whether it's cyber security, whether it's shielding from physical threats, electromagnetic threats, and all these different elements.
Yes, thank you for this compliment. Maxime, do you want to work on that?
Yeah, I just wanted to add that, of course, it's from civilian perspective, it's hard to get to the military requirements. However, we had so many examples of capabilities, tools, and solutions which can be for civilians and military users. And there's one common point with that the physical limitations in space create the capabilities and tools, and then could be just adjusted from civilian side to the military ones. And for instance, the Cosmos Climate is a great example of the dual use or different users capability, which could be adjusted to the users. Of course, there are some details behind classification, specific principles from MOD perspective, but still, the key is to invest in capabilities or tools which can be used for both users.
Okay, thanks a lot. Time is running by. We are approaching the end of our session, but just before that, I would like to come back to the example of space mining that you mentioned, François, because it's it's a very maybe a remote one, but we'll see in the future what it will be. But it's interesting because for me to illustrate the point bascule, the tipping point of an activity from an economic point of view. Because in any case, entering the defense market is a decision of a company. It's a company level decision for them to have an opportunity to expand their business with this. And the question is either it is at technological level or system level. So this is a question maybe for you, Victoria.
Yeah, thank you very much for that question. So I think from an industrial perspective, we're looking for opportunities, right, to mature technologies, to high TRL, to grow sustainably as companies. And so it's more interesting to work at a service level, and getting the trust and set up in place to do that and support that in a defense context does take a lot of communication. But we take for instance, the NATO commercial space strategy. It's very interesting. The focus there is really on services. It's not on just isolated technologies. It may be that military, on the ground needs require certain technologies that are not currently available, and that will be very interesting. But I think by and large, the majority of what we will see will be at the system and service level.
Yeah, definitely service more interesting from a commercial business perspective. Thank you, Victoria. Jan, maybe? François, you want to say something?
Yeah, if I take my venture capital hat, right? All these services, right? They need to be financed, and they have two ways of being financed: either by government or military, or by private investors. And for private investors to invest in this type of service, they need to believe that there will be either a commercial use case, refueling in space. Will it be in the next 5 to 10 years a pure commercial business, or will the military take the lead and will be able to finance, the couple of billions ahead of a pure commercial service in order to make this, viable. And we are right now for in-space transportation, right in the middle of this, whether it's going to be taken by the military or the commercial. And I would like to illustrate by two examples. Right now, if you discuss with the Space Force, they would love to buy, fuel in space, right? But for now, they consider that as a non-critical asset, and they don't want to finance it. And that's the situation. They're going to change pretty soon, because it's more critical than they think. And the second aspect is, when you look at the International Space Station, it's supposed to be decommissioned, right? And when we discuss with the head of NASA and the guys in charge of procurement, they would love to be able, for the next one, to buy just a service, right? But at the same time, there's no private investor that is fully willing to finance the entire space station, even if we see some private company like VAST with quite advanced, or a few others, but there's still an inflection point you're mentioning, where whether it's going to be government or commercial, it's not yet defined, right? And if the tension increase with China, for sure it will be government. But and so that's why also so many commercial investors are still waiting, because if this can be financed by government, it's so much better.
Thank you, François, for this example and illustration. Jan, maybe comment on this?
Sure. I think what Victoria and François said matches quite beautifully together. When we look at ESA, what we have at the civilian level, and also especially in FLPP with the commercial parts that are taken over, or the commercial steps that have been taken over the last years in FLPP to basically acquire private funding for these developments. In the end, what Victoria said, the MOD or the defense institutions, they are not interested in technologies. They are interested in abilities and in systems. And to first basically lay the foundation in ESA or the FLPP for technology developments that can later be adapted into, after they have been commercialized, can be adapted into a defense application or a dual use application or whatever. This is, I would say, quite an interesting step that can then be maybe taken on national level or EU level or wherever.
Okay, thank you. But mentioning technology and development, for example, for the refueling, this is, I think the INSPOC project we have to develop this future standard of refueling. I fear that, okay, so my timekeeper is looking at me. So I think we arrived at the last sequence of this panel. May I ask for each of you one takeaway you would like the audience to keep from this exchange? Maybe we start with you, Victoria, in this way?
So ladies first, even still at the end. No, for me, the biggest takeaway would be that civilian and defense have to go hand in hand. So that's why the work that ESA is doing with the INSPOC program, specifically with respect to in-orbit servicing, is so essential. And if we look actually at what Russia and China are doing, they don't really differentiate in their domestic market between civilian and defense. So they grow the technologies and mature them sort of in parallel and with great synchronicity. So it would be very interesting to have that reflected also more closely in Europe. So that would be my takeaway.
Thank you.
I would like to underline that we should stop thinking about dual use, that it's either for civilians or for military. It's about synergy between technologies for civilians and defense customers, and that's the point.
I can also underline that as well. What I would like to add is maybe also cooperation and communication on the institutional level of all institutions.
In principle, they are, let's say, they are on the same coins, but slightly different faces. And it doesn't mean that they cannot be on the same coin, but actually what is separating them is a matter of, let's say, how do you implement it in terms of technology, operational capability on system. They can let's say, coexist, but the main point is, let's say, we have to be clear what is for civilian part, what is for defense. So if we mix them up, it's a little bit, let's say, confusing. And what I feel also is there is a matter of national sovereignty, or let's say autonomy, and let's say countries' sovereignty that is quite much important behind the security issues. Security is a matter of let's say country prerogative. So.
And again, if we look at the amount that is spent, whether it's in Europe or in the US, for commercial applications and military application, especially in Europe, if you compare the ESA budget compared to what Germany, for example, is putting on their militarization of space, or what France is putting, we can clearly say that the business case for commercial startups or commercial players is in the defense. There's no doubt about that. And it's the same thing between NASA and Space Force budgets, first thing. And then second thing is the opportunity for ESA FLPP team to mature jointly some key core enabling technology that will be used by either one European country or multiple European countries together. But there's a clear need to mature this technology, anticipate the future need, for the benefits of the European community or each of the member states of ESA.
No, definitely. So thank you, and for sure, when you talk about defense, you are entitled to national sovereignty, etc. But as I said in introduction, the objective of today was not the who does what, but the what. Thank you for all the illustration and the valuable arguments you brought in this debate. So I think we have a photo, and then I will leave the floor to Kate. Thanks again.
Thank you very much, everybody. Okay, great. Thank you, Fred. Thank you, panel, for the really interesting panel discussion. It is already that time. It's time for our first coffee break. We've had a fascinating first session. Please, here, you can go and have a coffee break. Please be back by 4 o'clock in the room so we can start block 2, and people online will see you in half an hour as well.